starting soon, just waiting for people to join onto the stream. Okay guys, can you hear me okay? Haven't said much yet, so I'm just about to start. Got about 9 or so viewers, 8 viewers now. And as soon as you guys confirm that you can hear me, I'll kick off. Okay, cool, let's get started. So today I'm going to look at some BIOS utilities that do decompression and analysis otherwise of BIOSes. I've looked at some of these before. Hopefully there are some ones that that I haven't looked at. So let's just start off with yeah, it's good. I don't think I've looked at this one before. Okay, there's not much code here. I'll just get a it's not much code, so mem copies, no malloc. Just having a quick look to see what sort of functions we have. I mean, this code is quite small, so you can actually probably just look at all the code. To be honest, there's only 1,000 or so lines, so I just want to have a look at unsigned long. That's good for us that it's a unsigned long. You might have more integer bugs than an unsigned int. What else do we have? It's sort of a bit not too much. Not current positives. There's probably some bugs here, but yeah, current pos is a D word, so already you can tell that well, it can't work on files that are greater than 4 gig. So it's sort of a silly bug, but it's still a bug. I'll document it a bit later on. So F len as well. Okay, there are some bugs here. I'll document it down for a start. And this is just the age of the program, I presume. So I mean, you can do some funny stuff with this. So conceivably, uh, you could get a weird sort of integer overflow if you made a file of about 4 gig, made the block come at the end, and then it would go to an integer overflow and do other stuff. But it's sort of, it's sort of, you could create funny binaries probably, um, but what else do we have? There's some bugs there, but nothing too major. Really looking for memory corruption. What else do we have? I'm looking for some sort of buffer overflow with those F reads. If they don't use a fixed size, there's probably something there. Oh, that was pretty fast. Okay, let's have a look. That might be a bug here. Okay, this is good. So buff is block size. We go down here. Okay, so this is a bug. I mean, there might be something that let's copy all of it. Okay. What happens if is there so block is okay. That's potentially something useful. But let's come back to that. Something there though. It looks like it probably bugged. There might be some error checking code earlier on that prevents it from working. Now, remember that code, that dictionary bit size. I presume that's a signed integer, which isn't very good. What is this? strcmp string length. Found that. Buffer equals calloc, decode in3, is real len. It's an unsigned integer, it's a D word. They're all unsigned integers. I like that loop. Okay, so, well, that's just such ugly coding style, to be honest. Like, what is that? That is awful. That is terrible coding style. That is so deceiving. I would definitely change that. I think there's not much. I'm not exactly sure where that coding style would come from. Okay, so we've got loop. What is buffer? What is the size of the buffer again? 4096 bytes. Yeah, so I think this is maybe something. Loop equals temp. No, okay, no, it's not good. X2. Man, this coding style is simply the worst. It is so hard to read. So, okay, our buffer is 4096 bytes. We have a thing called real len. Where is real len updated? Okay, so we have now, I presume now is the plus equals loop, okay. And now is a D word, real len. So let's just have a quick look at this again. Okay, I think we have it. I'm pretty sure this is this looks like, so what function is this one? So decode M3. So I'm looking at if we can control, I suppose that's expansion length after it's decompressed, or maybe or something like that. If you make that real len, let's just see if there's anything else. So let's just check this buffer index 2. Okay, so no, there is a check here. So index 2 is bound to that. Okay, that's not a bug then. Damn it! I thought I had something. But hold it. No, we can't do it. I was just thinking if we made loop 0, then we would avoid that. But this is the only place where we write to buffer, I think. Except up here. But it has to be. Okay, now this is interesting. So dx so this is the only place where we write to that, and dx starts at presumably a high value. No, it starts at 0. So okay, so we this might be doable. So we read in. Okay, so dx starts at 0. The index starts near the end of that thing, and temp is we'll initialize that. So dx, the first it starts at 0, so that's 0. That's 0 again. It gets to that bit. Okay, so there's two bits. We have to make real len large, so to avoid this condition. Okay, so the first time it reads temp. Dx equals this. So then we control dx. And then we go into this bit here. So we make, let's say we make dx, we make temp, we make dx equal to sort of a 1 or something like that. Then we get to this bit, then we read the next thing, then we write to the buffer. We have that index as well. That's not a bug. It's not a bug. What am I doing? I'm getting worse. So index is protected as well. Is there anything else we can do? No, there's nothing we can do. And index 2 is protected. And index starts up there. Oh, it was worth a try. I don't think there's a bug in there. What else do we have? Size of P head. So definitely an attack surface is F-read. Calloc is the way that they're allocating memory. They're using sprintfs as well, which is sort of interesting. Decode M3. Found at, if we run out of code, we've got a buffer there. It's, can we overflow that buffer? Get module name. No. Nope. They used exit here, which is sort of interesting. They used return in main. Decode M3. Well, we're going to run out of code soon. Yeah, ran out of code. I'll just have a quick look at that. Decode M3 again. Just checking. Just checking. Running out of stuff in this code. No, there's not much there, is there? Kernel. make table. That looks actually something. Stuff like this might be interesting. Decode. Well, I can see a potential bug here. What happens if block size equals 0? X equals bit buff, this fill buff. Okay, so this is the getC, so it comes from a file, so that's okay. I'm going to decode C. Where is block size used? And it's a global. Well, it's a bug anyway. I mean, it's not a big bug, but because it's not actually used anywhere else. So it's a bug. I don't think it's used anywhere though. It's like, oh yeah, it's certainly a little bug. Let's see what else we can do. So get bits is our new I thought more would use it. Here we go. Okay, so PT len. There are some bugs here. I just saw one earlier, so that's okay. Yeah, this is, what can n bit be? Read PT len. Oh, okay, let's have a look. T bit, that's not much to work with. 5, nope. No. if you could have that actually arbitrary, you could get something useful. Can you make get bits return a negative? No, I don't think so. Use short bit. Am I? I think there's an actual good bug in here. Oh no, there isn't. There isn't. It's 128, so we need to make it's 19. Nope. PC table, that's okay. Okay, so can we control bit buff? So it's a short and it's being shifted 13, so it's only got 3 bits left, and that's not enough. But can we? Okay, so let's have a look. Okay, C equals get bits 2. So we get 2 bits, so the maximum that can be is 3. So that it'll iterate. Is C a short? It'll iterate 4 times. iSpecial I doubt will be somewhere useful. You'd think there's got to be a bug somewhere here. There's got to be a a bug. Okay, there's another bug here, decode C, ST. Well, maybe it's the same code that I saw. Can we control dic bit? Dictionary bit. Looks like we can't. So decode C, ST1. This is a bit complicated. So the idea that I'm thinking of is, can you get it into this second condition where you control J potentially, or if you can control J, can you make J 0, which would get this into an infinite loop? Okay, there could be bugs here. I mean, this is certainly, I think, worth looking more. Could be some bugs. So another thing, if you can get this, no, that's okay. Yeah, so the bug that you're looking at here is, can you get J to be 0, which requires C to be equal to offset, and offset is defined up here. Actually, it can't then, can it be? So UCHAR max presumably is 100, so it has to be. So you can't actually get it to be greater than that. But then you can get J to be a negative maybe. Get J to be a negative. Okay, there is a bug here, I think. So I think it's a bug anyway. Let's have a look at it. So offset equals, is that 253? Okay. Yep. Okay, so I'm going to presume UCHAR max is not defined here. I don't know why I'm looking this up. So that's less than or equal to UCHAR max, else C is greater than or equal to 256. Okay. If no, that's okay then. That's okay. C minus offset. That's fine. No, that's fine. No bug. Okay. That wasn't very... There are a couple of bugs in there, but nothing major. Nothing that you'd really write home about. What is this called? CMOS. Got another super small one. Looking for string copies here. Mem copies. Mallocs maybe. Oh, CMOS size. I like that. Load backup. going to load back up. And it's returning the size. Oh, there has to be a bug in here. I mean, this is hard to read code. Oh, God, here we go. Somebody's buffer. Oh, so what is that? So that's 512 bytes, so 1 kilobytes plus CMOS Max. So CMOS. Tylee CMOS Max. $4,096. Okay, so there's okay. Oh, that looks sort of okay. Oh, it's okay, I think. Now we get into this weird thing. Pos file. So the buffer has to open with this. Pos file. Some string handling. It's getting into another one. There is have a look up here. Oh, look, there is a bug. It's not much of a bug, but I mean, it is a bug. So It's a very small bug and not actually useful. Buffer is uninitialized. Read how many bytes if the file size is say 3 bytes. Read 3 bytes. Leave the rest of the buffer uninitialized. I know it's such a small bug, but you know, if you're a developer, this is something that you'd fix. And then we have mem compare, and maybe it actually produces something useful. Maybe there's like you know this is an info leak that if you run it enough times you can figure out, or you get timing attacks, or yeah, very small bug. There's just a comment on Twitch that the math is too hard for there not to be a bug in that function by IC manipulator, and absolutely right. Whenever I see and they fuzzed it in get full date. Oh, that's interesting. An arbitrary memory read. I think I might have to go back and look at it. But yes, any time there's multiple things going on here, but any time there's complicated processing, typically always you have a bug. I mean, it's just too complicated for there not to be bugs. I think that's a good observation, in fact. It's very interesting that people are fuzzing it at the same time. I'm curious. I'm curious how it goes. Let's have a look. So there's the uninitialized memory read again here. POS CMOS. Okay, so surely this isn't going to be a bug. And so can fread return 0? I think that's fine. So fread return 0. So this is actually a useful bug now. So let's look at this one. Tylee can be equal to 0 when a file of size 0. Then we get to this one. So this is 2 bugs. This is quite funny actually. So okay, so this is not 100% reliable. Uninit mem compare, possibly equals 0. pos. Oh wait up, pos file equals 9. Wait up, so pos file equals 9, pos file equals... Okay, no, that's okay. I'd say that's okay, I didn't see that. So tylee can be 9. When tylee equals 9, skip this loop. This is bound to screw up something later on. CMOS size equals 0 minus 1. Int underflow. And CMOS size where was it? What was a global? That's up here. Signed integer. Int underflow. Thumbs negative. Okay, so this is actually a pretty reasonable bug. Like will it cause a crash? So can you do something with that? Like it was obviously terrible code. It was a very a very long way of doing things, big function, so clearly a bug. Let's just let's just actually try to actually run it and see what happens. I don't normally do this in load backup. So is the function. So what's it called? CMOS password. Oh, I've got it installed. There you go. How do you do? There we go, minus L, so dd f equals dev 0, of equals my 0, we'll call it cmos.bin, size equals 1, count equals 9. So well, it did something then, so it didn't crash, did it? Let's have a look. Didn't crash. So what have I done wrong? So load backup. Let's just do an L trace. Did an f read equals 9. We did a mem compare. So where has it gone wrong here? Buff. So it gets to this one first. Okay, so this is, okay, so what exactly is going on here? So we've got an else. So this else belongs to this block. So we're clearly entering this code here. Else if mem compare. Is this just the oddest code? Is it just me? Where is this else belonging to? getting a bit more modern now. Okay, so else if that, else. Is it just me, or is this dead code? God, I hate this coding style. So we get to here, else if, else if, else if, else, new block. If this is not a bug because of this dead code, I am going to be so annoyed. Else. Here one. Fucking hell. Oh, sorry, I swore. This is just... I didn't get to there. So where is it? So where have I lost it? Year one. That's 9. Well, let's just see if I can do this one. Pause CMOS. No, I have to go to the next one. So we get to here. What have we done? What's the error from? Oh, there we go. I'm pretty soon I'm gonna run, I'm gonna reformat this. Really equals 9. So it must be in the same block, right? So we'll just go to here. Okay, so 4. I don't know. So they've got the... this one is the one that I want. Oh, okay. Let's go to... I think I'm tripping. I think I've literally been doing... Okay, so there's an exit here. Um, hmm. No, that's wrong, that's wrong. Oh, I can't do this one. Damn it! So what am I doing? So let me just recheck what I'm doing. We want to do this one, so we want to do echo. How do we get to this part here? So let's just add. I think I might have to use a debugger shortly. Okay, so there's an if, there's an else here. So it gets to here. Oh, there's a space. Oh God. Wow. I swear to God. This is this is actually not too different than being a developer, to be honest. So, okay, so I did. If you look, where is it? So, okay, so there we go. So we got, so we triggered that part. So, okay, it's. I swear to God, when I looked at this mem compare, I could not see that space. And what happens now? What happens? Did I compile it right? Just exits. So all of that, and nothing happens. So we have to do this other stuff as well, which we're not going to be able to trigger. And I'll just see what it came up with. And it's not even what I wanted. I thought it was CMOS size minus 1. Oh man. Oh man. This is this is not my day. What am I doing? Let's just look at this code again. So I was reading this as CMOS size equals CMOS size minus 1. I'm not quite sure how I got to that. Pos CMOS. So you can't, yeah, so pos, no, that's like pos CMOS. So pos CMOS is set to 0 here. That's okay. That's good. Yeah, that's good. So pos CMOS is set to 0. And that's the one that we want, I think. So we don't want that one. We want this one. Everyone thinks that it's auditing, you never make mistakes, but what have I done? Okay, so we did get CMOS size to -1. So we did get this to happen. The thing is, it's not actually leading to any useful bug. So after all of that, we got CMOS size to be the wrong thing. We can do it for this one as well, maybe. This is that, 1, 2. One, two, three. Okay, so that's that one. And then we have, so this is the first one, the yup. The second one we have this one, which we've also got yup for. We've got this one. Now let's just go further down. So we've got CMOS size to something useful, which is -1, and we return CMOS size. So we've got load backup. CMOS size. You have to be joking. There's a check for return is less than negative. Does it even return an error? I swear to God, this code does not check for an error and does not return less than 0 on error, but, or maybe it does. Let's have a look further up. It's this one. So this is the error. Oh, unable to read. Ah, oh, damn it. Okay, I think I might, I think I might call it a day. I've been going for about an hour and a half. Look, these are bugs. I mean, you're not meant to be able to get down that sort of code path and get -1 for load backup as a CMOS size. It legitimately thinks the CMOS size is at -1, but it turns out that it returns the CMOS size as -1, which is also the way that it returns an error condition, which is -1 as well. So it ends up that you don't get anything useful out of this particular bug. But is it a bug? Yes, it's a bug. It's absolutely. This is not meant to be like that. If you're a developer, you would fix this code. You shouldn't be able to do that. But we can just have a quick look if we can do anything else at this point really quickly. No, I think we'll leave it there. So there's definitely a bug here, and I'll document this up. I'll put this. Yeah, so I've got it here. Becomes negative. I'll comment that as well. But it turns out -1 is the error code for this function, and it returns CMOS size normally, if not on error. So we just error out in a strange code path. Oh, that's not the right one. It's this one. Thanks for watching. I'll see you guys next time. little frustrating. Thanks guys, see you later.